welcome everybody to this demonstration event of the EUreka3D Data Hub. It's my pleasure to welcome you to our first online demonstration event. So EUreka3D, it's a European project that is creating cloud services and storage and tools for cultural heritage institutes that need to handle 3D cultural heritage collections. And the aim is to provide an alternative for some of the commercial available tools and have something available which has been developed and hosted within Europe. So today is our first online demonstration event, and we will demonstrate to you the EUreka3D Data Hub. So we'll have a few presentations, and after that there will also be an opportunity to ask questions. So this is how the program will look like. So first there will be a brief introduction about the project by Antonella Fresa. And then thereafter, there will be a presentation by Ignacio Lamata Martinez, and he will be joined by Michael and Marinos to demonstrate the features and the workflow of the EUreka3D Data Hub. Then thereafter, we will have a presentation by Renato Santana of the EOSC, the European Open Science Cloud. And then finally, there will be an opportunity for questions and discussion, and that session that will be moderated by Valentina Bacci. So that's it from my side. So welcome to everyone, and I leave the floor to Antonella to introduce you to the EUreka3D project.
So good morning, everybody. It's a pleasure to be here online and to meet everybody who has joined our demonstration workshop. EUreka3D, as you heard, is a project, next please, funded by the European Commission in the frame of the DEP Digital Europe program. And it is in supporting the implementation of the data space for cultural heritage, which is the big initiative of the European Union, whose implementation is appointed to Europeana Foundation. Europeana Foundation is a partner of EUreka3D, and so we belong to this big family that is trying to implement a change, a transformation in the digital domain for the cultural heritage sector. We refer in particular in EUreka3D to the recommendation that was launched in 2021, where the member states were asked to invest and to foster energies in 3D digitization. And as you have seen in the previous slides from Frederik, we used the label supporting twin IT, that is an initiative in support of the implementation of the recommendation launched by Europeana Foundation. So the scope of this implementation of the recommendation is to acknowledge that the 3D digitization is not only for gaming and entertainment, but it is something that can help the cultural heritage sector to transform it digitally. However, to do this, there is something to be done. In collaboration with Europeana, but in particular also in terms of a capacity building that is not only the human capacity, but also the technology capacity, not only the hardware, but also the software, the standards, the guidelines, the resources, and the tools. Next, please. So EUreka3D has started on the 1st of January 2023. It lasts 24 months, and it is co-funded by the European Commission. This means that the partners are investing their contribution in the project. And it is a combination of the three pillars. The contents that must be of high quality, the cloud that must be European and providing all the services that we need, and the capacity through seminars, workshops, guidelines, instructions on how to use the technology. Everything is supported by wide and performing communication and dissemination activity. We have a website, and in particular, we have a blog, which is really the live part of our online communication, where we publish everything that is happening. And the blog is hosted in an existing magazine, digital-culture.eu, but it is also supported by posts on the social networks. And we have our channels on the social networks. Please, next. During the 24 months, we have to set up a pilot of what we are calling the EUreka3D platform, that is resources, computing, authorization and authentication mechanisms, visualization tools, the European Open Science Cloud, and capacity building in terms of execution of what is necessary to implement the recommendations that are in the VG study. The VG study for us is the reference, our point of reference. It is the study that has been developed by the Cyprus University of Technology for the European Commission. So it is paid by taxpayers' money, and it is in the interest of the whole digital cultural heritage sector to keep it into account. It is a study that promotes how to implement quality 3D digitization. We have events, and the event of today is a part of our program. We have editorials that are published on Europeana, and we think that we are progressing correctly. You can follow our news on the website and the blog and the social channels. And I have finished. I don't want to take much more time. We want to see the demonstration of the first results of EUreka3D. Thank you very much. The floor is yours, Nacho.
Yeah, yes, I know. So, morning, everyone. Thank you, Antonella. So today we are going to give you an overview of the EUreka3D platform we are developing, and also about the progress we are doing. So you need to consider that this is a work in progress. So not everything that you will see here is complete so far, but I'll show you how it works so far. So basically, if I have to summarize the project in a single figure, this could be it. It's an overview of the platform. As you can see, we divided this into three aspects. So one is the capture, then there is one that is the cloud, and then a final one that is the delivery. So I'll guide you through the whole flow. So basically, we start by an asset. For example, it could be a statue in a museum, or some other object that is of interest of the cultural heritage. And this real object, physical object, goes through a digitization process, as you can see here, where we use devices and some other hardware, specific hardware, to capture what we have here. So out of this digitization process, we get three categories, basically, as you can see here depicted. So one is the data, and it includes the raw data, everything that you capture directly from the sensors of a camera, for example, or any other particular activities that we might do in the digitization process. And we can divide this or categorize this data into these different types. So it could be 2D, it could be 3D, it could be video, it could be audio, or it could be text. So those are the main categories of the data, and we have all the data here. That's why I represent here like a 3D model. But we need to make sure that this is not only about physical structure. It's also capturing, Marinos probably will talk about this concept, about the memory of the object. When we get this object, it's not only that we get a physical structure in 3D, as we can see in games or any other platform, but we also get the whole history of this object with it. So we capture all this and retain this knowledge. And this is the main aspect in cultural heritage. So apart from data, we have also metadata. As you can see here, metadata is the data that talks about the model. So we use, in EUreka3D, we are using the EDM model, which is the Europeana data model. And is this format is based on RDF, but is this data model that helps you to explain what the model is. So you can have something like the name of the object, the description, the author, and some other things. And then we have the paradata. And the paradata is something very novel that we are doing in EUreka3D, and I think Marinos will explain in this presentation a bit later in more detail. But the paradata is the data we collect about the process. So it's not only important to say that this object has a name, a description, and also an author, and it was created in some century. Not only that, but also to explain how the digitization process was conducted, because it's not the same if we use a camera, a Sony camera that is a SDLR, or a mirrorless camera that is a Canon, that a new model. So these different devices and the process that we use, the temperatures, the temperature of the day we capture the object, the light conditions, everything affects how you capture the model. So this paradata is what we need to also contemplate, because it tells you about the quality of the model, and it also retains things that we might need in future to say, okay, this was not addressed properly, or this was done this way, and that's why we got this result. So it's also important to keep this. And I want to highlight that this is something very novel we are doing in EUreka3D. I don't think many institutions around the world are doing this sort of thing. So it's something that is important for us to say. So after we capture, we go to the cloud, and then we have to upload the data into the cloud. I call it here the EUreka3D platform, but it's like we say it's the data hub of services for EUreka3D. And in here, I want to highlight 3 components. The first one is the authentication and authorization. And this is the very important layer, because we need to keep things private as we need, and we need to authenticate users, and we need to make sure that the security is in place. So it doesn't mean that everything that we produce is not or needs some authentication and authorization, but because many of the results we do are public. But you also need to protect the platform, and you need to protect the data with this layer. After we have this layer, we can go to this other component, that is the data management. So, well, this layer is done by a product or a service called Check-in, that I will speak about it a bit later. Then we have the data management that is conducted by a product called Data Hub. And this is the layer that is in charge of managing all the data that we put. So all these data, metadata, and paradata is done, the management is done here. And as you can see, supported by storage. So we have some virtual disks, virtual hard drives that are in the cloud, and they support this thing. And as you can foresee, we need a lot of storage for some of the objects, because some of the objects might be very large. So we might have small objects that we digitize, but we might have even whole entire towns or cities. So it's something that we need to be prepared for that. And a third component of the platform is the compute power. So this is the cloud compute that we are running at TGI. And then we have this is basically related to the servers, the virtual machines or the servers that produce or allow us to conduct any processing on the data or delivery or things like that. As you can see here, I put that EUreka3D will be part of this European aggregator. So because we go then from the cloud, we go to the delivery phase. And the delivery, as you can see, we divide it into three components, but there could be more in future. So one of them is the 3D visualization, and this is conducted in EUreka3D through Europeana. So users, the way that a normal user will go and access our resources is through the Europeana website. They can go to the Europeana website and check the visualization of, for example, this object. So we can get from the digitization of process, we upload it, and finally it gets delivered to the user in the Europeana platform. If you need to download the data, because one of the aspects is that not everyone will be able to access the full results that we collect in this process through Europeana, because there are objects, there are assets, digital assets that cannot be presented easily nowadays through a web browser. So normally for this process, you have the download of data. So the user can go download the data and process and experiment and explore what it was done with this. So this is another channel for delivery. And finally, we have the EOS delivery. And for this, we have a special session today that will be delivered by Renato from EGI. So just after this presentation, and he will explain a bit more about what this means and how the EOS can help the cultural heritage community. So let's talk about each of these components in detail. So first, we will talk about the capture. And as I said, is this digitization process that we deliver, we get to these three outcomes: data, metadata, and paradata. And for this, I will let Marinos explain you better, because he's the expert in the field.
Good morning, everybody. This time from the capital city of the EU in Brussels. Thank you, Nazio. Now, we are at the stage where we need to create knowledge, where we create memory. Before that, the story. In order to be able to do that, we need to collect so much information and data as possible concerning the 3D. As you can see from our logo, EUreka 3D. You may remember the ancient Greek word Eureka is linked to one of the greatest inventions in the world. So we don't see a 3D as a geometrical structure anymore, but we see it as an object which has a story, has a hidden memory, and we want, with the power of the ICT, to bring the object to talk, to tell us its story. But to be able to do that, we need to collect on the day of the digitization or during the digitization, the data acquisition phase, all the related information and data together, linked in a such a way so that we can create at the end of the day knowledge. In order to do that, we need to collect the information, and I'm starting with the paradata, certifying that the data collection, the data acquisition is of a high quality, is of a standard, of a level of standard that can give us or can have an estimation at the end, give us an estimation at the end of the day that the collected data are correct and of high quality. So, paradigm. Ignacio mentioned earlier, it's not only the issue of the data, but the environment in which we collected the data. Let's say, under which conditions. It was a temperature of 40 plus degrees when we took our laser and we went to the site to digitize the monument. It was a sandstorm, it was raining, it was snowing. who did the digitization, was an expert or was just an amateur or a student or a technician. We had devices in place which were well manufactured, calibrated, and all in such a place so that we can, at the end of the day, certify that our data are of high quality. And of course, this is a multimedia collection of data. It's not just only the 3D. It's also the images, it's also the audiovisual behind, the text, the books, the stories, and so on and so on. So if we then move further, I have a very good example here from the oldest fisher boat in Cyprus, the last existing fisher boat. It's very modern, it's 80 years old, but nevertheless, it is the oldest existing, with a very, very complex and very difficult data acquisition in place, where we tested the EUreka3D methodology and the VG, of course, study results. You will see here some of the reconstruction, let's say, steps, how we created at the end of the day the 3D structure. Please have in mind that the geometry here is one of the most complex existing at all, so far as mathematics concerned. NURBS, freeform surfaces, non-uniform rational B-splines are the most complex existing. And nevertheless, we managed, we created the boat, and the boat is currently the data handed over or partially handed over to the naval engineers and to the technicians to proceed with the restoration and the preservation of the boat. And you see now here one of the examples for the use of the data as a game in the form of a Lego for small kids in the elementary school. It's a work under progress, and we are just in the middle of our project. 1 year is behind us. So we have another 1 year to go. And next year, that time, we will be able to show to you more results. Another very good example, we are moving from the sea, more in the center of the island, in an abandoned village, late medieval one, which is in the tentative list of UNESCO, which has been fully digitized using aerial as well as terrestrial data acquisition devices. It's again the first time happening so far as tentative list objects by UNESCO concerned. And the data are currently in process to create the HB model of the entire village. We of course collected all the information related to the village, to the memory, to the story. It's a part of the value of the 3D, yeah, EUreka3D. We give a value to the 3D by embedding its memory. A nice one example, you can visit the website, the platform that we created, ificardo.eu. QR code is there, you can scan it. You cannot enter the code now via your mobile, and you are landing on a virtual space where you can get a part of the memory of the village. By doing that and going to the press and announcing that on the island, village informed us last week that they have a problem. And the problem that we created there is that local visitors, a high number of local visitors, Cypriots, are going now to visit the site. the situation is under control, but nevertheless, that's one of the impact of the project results. Now, the village, as you see it here, in the form of temporary 3D results, is going to be on a level of detail, as we said in the BIM, Building Information Management Systems 300, which is accurate geometry, but we move also to the L400, where we're going to have geometry plus the pathology of the buildings. Ignacio, floor is back to you.
Thank you.
Thank you.
So this is an example of metadata in EDM format. It's a very simple example. It's nothing really complicated, but just to give you an overview of some of the data that we can include into the metadata. Things like the description, the format, the rights, many other things. But it's just to give you an impression of how the metadata will look in EUreka3D in the Europeana data model. So once we have completed the trip through the capturing the digitization process, it's time to move to the cloud. And in here, I want to highlight these three components again. The first one is the authentication and authorization that is run by check-in, the data management that is run by Data Hub, and the computer power that is run by Cloud Compute. And also I will talk about the infrastructure manager, which is a tool that helps us to deploy things in the cloud. So I will go one by one to show you what we have and what we are doing in each of these aspects. So starting with the authentication and authorization. So check-in is an identity and access management system. And it means that it's a service or a tool that deals with authentication and authorization. So I will explain exactly these concepts for the audience, but basically the authentication is the process to collect who you are. So it's the process to verifying who the user is, that you are who you claim you are. And the authorization is the process of assigning permissions or verifying the permissions that the user have in a system. So check-in also assists with GDPR compliance and is also a registered member of the EOSK-AI Federation. What means for us is that we can, with no effort, accept the users coming from EOSK into our platform. And the other way around. So the users of Eureka can directly go to EOSK and they don't need to do any extra steps. They can just simply use our system and they are connected, let's say. So we increase the base, the user base of our systems, in both directions, let's say. So as I say, authentication is to prove who you are. And normally what we do in the real world is to prove it with different mechanisms. So we can have a password, for example, we can have a hardware device, we can have a code that is in our phone, additionally to a password. So this is what is called second factor authentication. And we can have biometrics as well. So we can use the fingerprint or things like that. So this is how normally we prove this. We need to consider that authentication, even though it's a process to verify who you are, normally the digital world, it doesn't work like this. So basically what you consider is that the person that is claiming to be someone has one of these proofs. So if I steal the password of Bill Gates and I use the password of Bill Gates, I am proving that I'm Bill Gates in the digital world. It's not real, but until we get this DNA test or whatever, the authentication is normally done by these systems. Also, authentication needs to be a balance between, this is something common in security, it should be a balance between easy of use and security. So you cannot put a lot of stress on users to use a password plus a hardware device plus a biometrics, because then the user will not care about using your application. So it's something to consider. So normally in the real world, what we do is we check in, for example, we allow authentication through your home organization. Normally, it could be an organization that is part of EduGain. So, for example, universities, research institutions, everything. And then we allow also authentication process through other examples like I put here, like Google, Facebook, LinkedIn, Orchid. There are social accounts and things like that. So basically, users just need to use their own home organization and get authenticated. And it's very important to remark that check-in doesn't authenticate you. Check-in trust, for example, the University of Oxford, so you use your own organization to log in, and then check-in trust the University of Oxford to say, okay, this is the person who claims to. Authorization on the other side is what you can do in the system. And this is normally done by attributes or roles. I put here two examples. One is with Linux or Unix-based systems where you have these permissions on the files and what you can do. And then here is the similar thing with Windows. So how people can access, for example, a resource in the system like a file or something else. In EGI check-in, we use, or EGI in general, we use the concept of virtual organization, or VO. So a virtual organization is a community with common research interests. So it's basically a group of users, and it's also the mechanism that we have to grant access to resources and to organize users. So basically what it means is that we have a virtual organization that represents a community, and then we can have subgroups inside this community. For example, here I depict a cloud operators group that we assign the permission that they can manage the servers, for example. And then we have some users of an application that it could be, like in this example, notebook users that can access the application. So this group of users, they cannot manage servers, and cloud operators by themselves, they cannot access the application. So we restrict this. And we also have a VO manager that is the person or person in charge of organizing this and assigning permissions and things like that. So they are responsible for the virtual organization. So this is how we coordinate and we organize communities in EGI. And in EUreka3D, we have our own virtual organization that we use to access EUreka3D resources. So the way to enter the community is very easy. You just need to register the check-in account. And basically, the way you have to do is basically to follow a login process. So normally, to register the check-in account, you go to check-in, to this, well, I will show you in a few seconds. So you need to go to the main screen and log in with your organization, and that's it. So if I'm a member of the University of Oxford, I go use my credentials of the university, log in, register the account. And then you need to join the Cultural Heritage VO, which is the one that we are using for EUreka3D. This is very simple. It's just following a URL. And we have a manual approval by a VO manager. So there are some VO managers in EUreka that will approve your request. I have to say that it's not intended. So I'm showing this in this workflow, but it's not intended for you to join the EUreka3D VO because we are still in the process of developing. So, I mean, if you try to join, probably you will be rejected at this point. But I want to show you a feeling of how it is. So basically, you just go to the main screen, you log in through your credentials, and you register. This is basically the process. But as you can see, I'm already registered with some of the providers. So basically, you come to this screen and you have to choose your, let's say, if I was in Oxford University, I can go to the University of Oxford. I will be redirected to the usual screen, the login screen, and then I will log in, and that's it. So that's how you register. The same process applies to Google, GitHub, anything else that you do. So normally you go to the account that, sorry, the account you want to use, and then log in, and that's it. So this is the registration process, which is very simple. And the registration in the VO, it's also very simple. You just follow. You need to have an account. That's why it's required as a first step. You log in, and then you get to this screen. It's authenticating me. You get to this screen where you can join the VO. You just check begin. And unfortunately, I'm part of the VO already. but the process will be that you will be asked for some details if necessary, and then you just click OK, and that's it. So it's a very, very simple process. So now we are going to explain Data Hub, which is a product based on One Data. And for this, I would like to give the floor to Michael, who is our expert in Data Hub, to continue the presentation.
Yeah, hello. I just need to share the screen in order to show the demo later. So please stop sharing.
So Michael, please.
Please stop sharing the screen so I can show the demo later as well. Okay. So everyone, can you hear me, Nacho?
Yes, we can.
Yeah, perfect. So One Data is the data layer that is available for the EUreka3D project. First, the small commercial. The One Data is the project developed in the Cybernet Data Center at the HGH University of Krakow. We've been developing it for over 10 years now, mostly being funded by various European projects and organizations throughout which we were developing our use cases and engaging in different scientific communities. And our vision is to deliver a data management platform for large-scale and distributed problems. For example, multi-cloud computing, hybrid cloud computing, address the challenges of global collaboration and data sharing across organizations, like in EUreka3D, and streamline the data processing in heterogeneous storage setups, because in different data centers, one might expect to have different kind of storages that need to be aggregated under one physical storage. So the EGI Data Hub is the service that that is managed by the Cybernet data centers, hosted in Cybernet data center, and it's the EGI entry to the one data service. At the moment, the EGI Data Hub serves about 2,150 different data spaces. You can think of it as virtual directories. It serves 20 different sites where dedicated services called one providers, which basically act as data proxies, are installed. About 2 petabytes of data, and it's all being collaborated with about 700 users. Apart from that, of the EGI Data Hub, some of our organizations are hosting their own one zones, and at the moment we are also conducting the project for the national museums of Poland, where we are exposing from 5 petabytes to 10 petabytes and 100 million files of the historical digitalization of Polish artifacts. And the EGI Data Hub in EUreka3D serves as a dedicated cloud resource hosted in Cybernet data centers. We are providing 50 terabytes of the dedicated object storage for 3D models, a virtual data space for everyone in EUreka3D to collaborate and upload their data. It gives the possibility to manage the metadata as well as the paradata from the perspective of the service of the uploaded 3D models, querying the uploaded files by the metadata. For example, you can ask the question about the date of when the object was scanned or when it was uploaded. We are also working on the dedicated workflows that might be useful for the process of compression of uploaded 3D objects, as quite usually the original files are quite large. And it's impossible to serve them live to the users. So some kind of automatic post-processing workflow for actually enabling the 3D objects for the efficient serving them via web is valid here. And now the demo.
Yeah, I can take over. I would like to give you a feeling of how it works. So it's a very simple test. Let me open actually this way. So normally what you do, you go to Data Hub. If you are already logged in EGI through EGI check-in, you get the screen directly. But normally you will have to go through this process. You sign in through using EGI. Then, as you can see, you will go through the same process that we saw before, where you can choose the system that you want to use to authenticate. And once you do, you will be inside here. So as Michael explained, there is a EUreka3D space for this, and we can upload files here. So the way the system works, we are also working on some, as he mentioned, working on some integrated workflows, something like that. But basically, you can see it's very simple because you can create folders here. Let's say example Brussels, and it's as simple as getting your objects and dragging and dropping. It's extremely simple. I mean, it doesn't really require any expertise to do this. So this is basically the graphical user interface of the system we are using, which is just as simple as this. And then we have, of course, a lot of functionality. I don't know if Michael wants to highlight something, but we can create metadata. We can, for example, here in a key value format, we can input a JSON, RDF, anything here. We can also assign permissions. We can share. We can open for open access. So there are a lot of functionalities here that we can use. But I don't want to spend much time on this because I just want to give you a feeling of what it is and how it works. And I think this is enough. If someone has any question or wants to have something more detailed, we can continue after this. Okay, so let's continue with this. Oops. Okay. So to give you where we are, so we explained the authentication and authorization component. We explained the data management, and oops, sorry. And we are going to explain now the computer power. So, okay. Let me check if I can get back to this one. Yeah. Okay. So the computing power is done through the EGI Cloud Compute. It's the provisioning of virtual servers on the cloud. Basically, we allocate some hardware that is available for the project or the community, or in this case, the virtual organization. And then basically you assign some CPU, some RAM memory, some storage, and network connection. And then you allocate these and assign them to virtual machines. One of the good things about this is that it gets this concept of elasticity in a way that is scalable. So, for example, you can create a server automatically, and then if the load or you have too many users and one server is not enough, or this hardware allocation is not enough to cope with the workload, you can create automatically another one or two more. And that's why this elasticity, you create, you assign hardware resources on demand as you need it. So this had a lot of advantages because this is virtual, it's not physical, so you don't need to go through your bureaucratic processes in your company to buy new hardware, get it approved, deliver it, this sort of thing. So you have it all ready for you to be used as you need it. So for EUreka3D, we use CypherNet, the CypherNet cloud compute part of the AGI Federation, and we allocated currently some specifications. So we have 32 CPUs, some gigabytes of RAM, 2 public IPs, and some 1 terabyte of storage. So this is what we have allocated so far for EUreka3D. And to support this, so basically this is the allocation we have in terms of hardware, but we are using a tool called Infrastructure Manager that is also an AGI tool, and it helps us to deploy servers and hardware and even software on multiple clouds in a user-friendly way. So it can also enable the automation of deployments in the cloud, and it's a very easy tool to use. I will give you an example now. But it's something that we use to create our servers in an easy manner. It's not necessary to use Infrastructure Manager, but it helps a lot, especially for people that are not technically savvy. It's very easy. So you just get a dashboard and you can decide what to deploy there. You put the specification and it is created for you. So for example, for Eureka, we can create this machine and we put a specification of what we need in the cloud and it's automatically done for you. One good thing about this is that Infrastructure Manager not only works with AGI, so you can deploy on the AGI Federation in any of the cloud compute providers we have, but you can also use private companies like Amazon or Google Cloud or Azure. So it's something that is ready, so you can create your templates, automate it, and use it in either cloud. There are a lot of clouds that are supported. So to give you an overview, so for the CypherNet cloud, as usual, we log in through check-in. This is using single sign-on, so meaning that because I'm already logged in, I don't need to log in again. You see, I'm accessing different applications, and I don't need to log in again. It's already logged in. So it's opening, and you can see here, for example, the dashboard of this cloud compute, where we have the allocation of CPUs, the RAM, the IPs, and some of the aspects like the storage. So this is for the cloud, and for the Infrastructure Manager, similar thing. I log in through check-in. Well, you can see I deployed a lot of machines here, but you can get an overview of the machine. Here you can get the IP, you can get all details about how to connect to the machine. And the way to deploy something is really easy. I'll give you an example. So for example, you can see you can do a lot of things. You can deploy Kubernetes clusters easily. You can deploy other applications and they install everything for you. The tool installs everything for you. So for example, if we just want a simple VM with Docker, we can do this and we install Docker. We configure, and then we just specify the number of CPUs, the number of gigabytes of RAM we want, the number of CPUs. If we need a GPU, we can have also some configuration for Docker, and we can decide in which provider to do it, and then we can deploy in this machine. So we can deploy an Ubuntu server on this cloud, and I click submit, and it will be done for me. So it's a very simple product to use. Okay. So let me get back. Okay, so finally we get into the delivery section. So we went through the digitization, we upload everything in the cloud, we have the authentication, we have the data management, we have the cloud power, and then we go to the delivery. In the delivery, we are dealing with different things. One is the integration with Europeana. And for this, we are using OAI PMH, this protocol to exchange metadata information with them. And then we are also using PID. So at the moment we are testing this B200 handle account that is part of the project EUdat, and they provide permanent IDs for your objects in a way that we can assign a permanent ID to the objects we upload in Data Hub. This is already connected to Data Hub, so it's transparent for the user, let's say. So you just upload something, publish it as open data, and request to collect a permanent ID, persistent ID, and then you get it. And the object gets this PID, and that's it. So it's a very simple process. And then in another aspect, we are testing the visualization. So we are testing different libraries for the 3D visualization, because Europeana is dealing with metadata, but the visualization has to be run in the different distributed environments. So as we upload data to Europeana for visualization, this has to be rendered in our own computers. That's why we have this computing power in the project. So for the demo, I just want to show you an overview of the visualization, but you will see this is simply a very easy test that we are doing. So this is something running in our machine. So this is in EUreka3D computers, the one that I showed you before in Cybernet. And this is the aspect that we are dealing with. As you can see, this is a prototype. It's not well decorated. It's just the logo of EUreka3D in 3D, basically. So you can see that it's a 3D object and it's rendered by a visualization library. So this is basically what we are dealing with. So once we get this product, we can deliver this to Europeana and we can show the object. In this case, it's a simple EUreka3D logo, but it could be something else, more complex and more interesting, basically. For the data download, we have the Data Hub. So basically, it's as simple as going to the files, and there are many, different things to download the data. If you have access to this, you can go to the boat and, for example, get some object and download it. You click download and you start downloading it. So this is one of the ways to do it. Another way is to use the to publish it as a public object and get the URL of this and download it from outside. You don't even realize that you are using Data Hub, basically. So let me collect this one. So it would be something similar to this, where you access this URL that you can have in a website or whatever, and then automatically you download a new object. So I'm downloading this EUreka3D logo, let's say. So this is basically the download. This is an easy process. It's nothing really complicated, to be honest. And then we have the integration with Europeana. And in here, I want to show you the progress we are doing. This is a test, so it's nothing that is complete, but it's to show you, to give you a feeling of what we are doing. So basically, we go to this Data Hub instance where we have the files, and we fill. In this case, we do it manually because it's a proof of concept. We are just testing the platform, but we paste here the metadata in EDM format that we want to have, and we publish this as open data. So let me show you actually how it works, but it's something similar to this. So we upload, share, okay. Then in here we publish as open data, and in here you can choose for example, this B200, and this will assign a PID to this object. But as you can see, it's as easy as this. So you just click and the PID will be assigned to you. Then you paste what you need here, the metadata of the object, and it's published. And on the other side, which is the Europeana side, they will get this information through the OAI PMH protocol. And in here is one of the tests I did, and I will show you how it works. And through the EUreka platform, you can check how this object would look in the website. So this example is just a 2D object. I didn't upload a 3D model, but this is let's say it's a photo, but it eventually will be the actual 3D model that I showed you before. And then you can see all the information that you fill in. In this case, we have just testing information, but you can see that the link between Data Hub, which is the platform that we use in EUreka3D, with Europeana is working. So this is the current status of the task. It's something that we intend to develop fully in the next few months. So, but this is the progress we have. And I just wanted to share with you where we are in this aspect. So basically, that's it. And I just want to recap using the initial figure that I showed you. Let's go to the beginning. Sorry, it's faster if I do it this way. So basically, we show you in this presentation the capturing process, and Marinos talk about this. Then I showed you the cloud with the 3 components: check-in, Data Hub, and the cloud compute. And then the delivery, I'll show you the progress we are doing to show this in Europeana, how we can download data. And now it's time to introduce the EOS. And for this, I will stop my presentation, and Renato will tell you about this EOS part.
Hello, can you hear me?
Yes.
Great, thank you. I can show up my face or not, doesn't matter. Good morning, everyone. Thanks, Nacho, for the floor. And I'm going to talk about as fast as possible. I'm running out of time about EGI, EOS, and EUreka3D, about this project that we are part of it. I'm Renato Santana, part of EGI team here, EGI Federation, which is based in Amsterdam. And I'm also based here. Sorry if I got any background noise here, but I'm at home office. So we're going to talk about what EGI, a little bit of history and services, and EGI communities, also examples, how we provide services, and what EGI is, and how we provide the services, etc. And collaboration opportunities, and talk about, of course, EGI and EUreka3D. Let's talk about the beginning of everything. In the beginning, there was nothing. And then there was a big bang. Well, that's a lot of backup history to catch. But that's how we started here with this big circle in Geneva and France, right in the border there, where we have this the biggest machine that man created. It's a tunnel, 27 kilometers tunnel, where it's proton, from the helium. It's just a proton accelerated to the speed of light, and then they collide in 4 huge caves. It's everything underground. It's a tunnel, and from these collisions, they have these subparticles. So what physicists wants to see, they have been seeing a lot of things, is to simulate or emulate or repeat the Big Bang with the origin of the particles. They just want to know where we came from and where we are going. Very humble things. But this was the origin, from where EGI came from. Also, we came from there. And this is we have 4 caves that I said. There are 4 VOs, virtual organizations. So each experiment, they have their own way of seeing things. They have own objectives, and that's what a VO that Nacho just explained. The VO is a group of researchers, a group of people who use the same kind of software, software data, and they are protected. I mean, even being at CERN there, you have 4 experiments using the same tunnel, the same experiments, collisions, etc. They have different detectors and they have different purposes. And they want to protect their data. There's I don't know how many years, and then they make it public. But while they're doing research, they want to protect their data. That's why they use authentication and authorization. I mean, there was a question about this. And you have to be authorized first just to know who you are. EGI provides to experiment to others, I mean, VOs, to other virtual organizations through AAI, authorization authentications infrastructure. So you can be authenticated by your institute for research institute, and then from your VO, you can access whatever the VO wants you to access. That's the idea behind this virtual organization and this authentication and authorization infrastructure. Well, from CERN, we started. Well, of course, there was a spread of these virtual organizations, Virgo, IceCube, Instruct. I mean, they're all NS, MSO, I mean, more than 250 VOs we have at EGI. I mean, we have these, not control, we provide these services, but now we have more than 250 VOs. I believe that the biggest one are these at CERN, the 4 experiments. I believe Atlas is the biggest one. They have more than 4,000 people, researchers all over the world. And that's what we have been doing from there. So EGI, our vision is our researchers have seamless access to services, resources, and expertise to collaborate, conduct world-class research and innovation. The EGI Foundation, which is us, non-profitable company, enable the EGI Federation to serve international research and innovation. And we provide this federation with this huge amount of resources. We try to deliver open solutions for advanced computing and data analytics in research and innovation. Going back to this, just to give an idea about, there was a question about 50 tera. CERN is talking about not about petabytes storage. They're talking about exabytes. It's 1 million terabytes. And they use they're part of our resource, federation resource. These are just storage. I mean, computing also is a huge amount of resource. So that's our idea, our vision to use the federated resource. Here on the right here, you can see the grid sites from CERN grid sites. They are all over the world. And maybe this is not a real spot, but there are more sites than for CERN. In this case, CERN is the central one in Switzerland. Then comes the tier 2s, the tier 1s, big computer centers, really high speed networks, bandwidth. And all over the world, data is sent, computed, and sent back to CERN. So the physicists can visualize what they are trying to catch. That's the main idea from CERN. I mean, that's one of the VOs or 4 VOs that we're talking about. EGI wants to, our main purpose, our federation of resource is for computing data intensive sciences. We can, those types of services, computing, cloud computing, high throughput computing, security, identity through this check-in AAI that just spoke, service provided by AGI Federation, compute orchestration, which is, the name says itself, it's to orchestrate, it's to manage resources, cloud resources also, training, FITSM standards, ISO stuff. We do also applications. There's notebooks, is an infrastructure so you can run your applications and do your stuff. And storage and data, of course, I just mentioned Data Hub, Data Hub. I mean, Nacho just demonstrated Data Hub. You can storage the data, etc. There are several other. Those are the basic services that we can provide through our EGI Federation. Just to mention just few numbers: 84,000 users, 7 HTC CPU hours consumed. I think that was 1 year, 7.1 billion hours consumed. Almost 2,000 articles produced. EGI Council, we have the council. It's not it's a distributed also. Not only the resource, but also the management, and the council is. We have 29 participants, and those are other numbers. They are located here. This presentation I'm going to leave to after this, so you can have a look for more details. And back to EGI, you have the communities, the scientific communities, representative. Their groups, their VOs, and we have the resource that we can provide. EGI is the middle of, it's a broker, it's a negotiator, where we can match the necessities from the communities, providing resources. We also monitor we have several level agreement, SLAs. We have operation level agreement also, which are verified, and we can guarantee, ensure satisfaction from the SLAs and from OLAs, the operation level agreements. And we are also ISO certified stuff, 27 also, security standards. This is FITSM is like ITU stuff, which is smaller. And we also have standards we can train also. Well, just a lot of things. So sustainability comes from institutional commitments, complemented by project funds and pay of use. Pay of use will depend in the case, of course. There was a question, I don't remember, Sebastian, asking about the 50 tera. 50 tera, if you see, yeah, we have a resource for exabytes, so it's for the project, it's free. We are having a demo, we're demonstrating, and well, in the future we will see. But in principle, 50 tera is nothing really too much. Our GI services in community specific platforms. The AI we have already been speaking about. Composable, use services from different layers together to build new solutions. API driven, we can also have API stored and use APIs to intercommunicate, like we are doing with, in our case, EUreka3D to Europeana. Customizable. We can custom figurations, etc., AI datasets, interoperate with EOSC. I'm going to explain a little bit now. And we're building partnerships, not only IT platforms. A little bit of these, 2 examples that I got, WNMR portals. This is let's say, big VO. They do, I'm not an expert on this area, they do biologics research. On the left here, they have 7 applications portals. They do genetic stuff. And just to explain a little bit of what we provide, the services we provide, they have the validation, authorization, again, pre-processing. They do also processing stuff. They store data. They output their file packing, whatever, Chimera. They have a lot of services that they use, and here's the exposed to the web client. So they input the data, and then all the process, they have this, and the web server, the master node, working node, etc. They process, they run simulations, they use a lot of resources. It's a big VO that we have. Let me see if I can show this. Use per year, they use like 7,000 almost DVUs. EGI service used high throughput compute, cloud compute. They have software distribution. What software? I mean, it's up to the VO, to this WNMR VO to do it, to run it and control it. I mean, that's again why we have this controlled access, workload manager and checking the AI. That's what they use. There's another VO they call ANS, Data Exploitation Platform from Climate Research. They also use from the bottom, the 20 petabytes community legacy infrastructure, community specific data access services, etc. They use the AGI Federation data serving from this data. They filter, they organize the data, and in order to show it, they use application scaling. So through several tools that we have, Kubernetes, whatever, EOSC data sharing services and interfaces, infrastructure as a service, as a cloud services. EOS Compute Services integrate, so they have their EGI notebooks that I mentioned before, Jupyter Hub. So they use a lot of our infrastructure. Another example, data federation for plant phenotyping, and by emphasis, it's another experiment, another VO for us. And they use data analysis, AI for EOSC, platform hosted by our models, like we intend to use EUreka3D probably. Authentication, EGI, also EUreka3D, we intend to use it up to a level. Everything is going to be hide. I don't know yet, but of course that there's a portal for this village that Marinos explained, which is open, anybody can access. But the experiment has some data and tools and software that has to be protected or not. That will be decided by the project, EUreka3D. This experiment also use cloud computing at CESNet, dynamic DNS services. This is a little bit too much of the services, is technical stuff. Storage, connect with the online in France, through IN2P3, and also another site, the part of our EGI Federation, connected with the S3 storage data hub based on technology, etc. I'm trying to run a little bit, I'm running out of time. A multidisciplinary, so what is EOS? Since 2018, there were projects. I'm not going to show all the continuity of the project, but it has been continued, even by project by project. We have been trying to guarantee the legacy from the projects, etc. EOSC, just a simple definition, a multidisciplinary environment where researchers can publish, find, and reuse data, tools, and services, enabling them to better conduct their work. So some strategic view, maybe it's a little bit too much, but what is EOSC? Is an European web for fair data, where we provide easy to find, access, interoperate, and reuse. So it's one definition for fair data. Why? To unlock the full potential of research data to accelerate discoveries in innovation. How? Enabling definition, having standards, and development of tools and services to allow research to find access, establish a sustainable and federated infrastructure, and ensure open science practice and skills are rewarded and thought. So this is the architecture. Again, I'm going to leave all these details in the presentation for you when you want to have a look. Horizontal services, for instance, the core services, EOSC federation stuff. Data federation could be VO federation, EUreka3D data. Interoperability, that's a layer for interoperability features with Europeana, for instance. and also EOSC Exchange, computing thematic services, etc. The building elements of this is a micro view overview. EGI in the European. Okay, what's then? We have EOSC and EGI. EGI is an EOSC provider. Using services from EGI means using EOSC services. EGI provides core services in EOSC. I mean, using EGI Federation means using EOSC, and vice versa. And such as AI, I have already spoken about this, authorization, authentication, infrastructure. EGI will support EUreka3D, is already supported with the, EUreka3D is, under my view, it's a pilot or initial infrastructure that we can provide EUreka3D, the community, the digitization, an infrastructure that will grow up to that certain level. But the project is short; it ends next year. So our goal is really to EUreka3D to provide this infrastructure that may be used or not in the future. We can adapt and change anything. But this is one way of accessing, one example, one way to access EOSC is Marketplace. Pros Marketplace, this is opened through EOSC portal. This is not clickable, sorry. So through Marketplace, you can store, you can produce, you can make publicity. So you have several types of ways of using Marketplace. This is one example of a software, which just by chance, it was a coincidence, this EUreka3D Omega XST. And I wanted to mention this, resources are provided by institutes, not projects. So I have been talking about projects, but we have
Renato, I'm
Yes?
sorry to interrupt, but we are short of time and there is various questions in the chat. So if you can quickly wrap up, thank you.
Okay, so I'm trying just to show this KU Omega thing. There's another way of requiring, for instance, if you want to catalogs also, if you want to have a cloud computing, you just click here, click there, sorry, and you can get infrastructure from general purpose or high memory resources or GPU, and you have a contact for your portals. I mean, there and questions. Okay, it's almost there. EGI works as a negotiator broker between communities and resources available. From EUreka3D project requirements, an infrastructure will be defined and structured and making available, but again, not with 4,000 objects and everything. We're going to have some small collection of very nice examples, and it's going to be a success for sure. Several types of resource, and the EUreka3D is a project digitation, pilot initial base for next steps. And I think that's it. Almost there.
Thank you very much, Renato.
Sorry, I had to run at the end.
No, yes, but we saw that there are various questions in the question and answer, so we really want to try to address all of them. And yes, maybe I can pass directly the floor to Nacho and to Marinos to reply to those questions. Please, Nacho, the floor is yours again.
Thank you.
Nacho, it's blurred.
Sorry, but the camera is not working for some reason. But anyway, well, okay, I'll try to answer. Let me share my screen. Okay. So there is one question that is marked as answered, but we didn't answer. I don't know if they got an answer, but it says, related to the 50 terabytes, any ideas on how choices will be made on what to host once the 50 terabyte limit comes into sight? Is it free for all? Will space be assigned? And also probably related to this, 50 terabytes for 3D models sounds like a lot, but is there any indication of how many models based on the average size this can host? So as a starter, this 50 terabytes is just the first phase for EUreka3D, because in the project we promised 300 actually. So it's even more than this. And if you consider, for example, 4,000 objects, we can store, or we can have 75 gigabytes allocated per object, which is quite a lot. Regarding the how many models, so yeah, it depends. It's a lot, but it depends also on the object. So, for example, Marinos might correct me even better, but you have a small object, you can take many of them in here. But if you have a big town, it's even good enough, because consider 4,000 objects, 75 gigabytes per object is quite a lot. I mean, you can keep a lot of things. And probably Marinos want to add something to.
Yes. If we would like to collect during the data acquisition all the information and all the data related to the tangible object, then we need space. As I mentioned in my part of the presentation, we are talking here about a new era so far as 3D documentation concerned. The name of the project is EUreka3D, and it's knowledge-based 3D digitization. It's not anymore a geometrical, just only geometrical documentation and nothing else. We are collecting the entire story and memory of the object. So therefore, in this holistic digital heritage documentation, on the time of the Eureka 3D way forward, we need space. And even this space probably could not be enough. What is the space that you need for a piece of story? You know very well what we are saying about one image is a piece of paper, but has a story of 1,000 words. And sometimes not only 1,000 words, 1,000 chapters, and so on. So it's not an issue of defining the bits and bytes. It's an issue of let's get everything together now when we have them in front of us and we face the challenge of the holistic documentation.
And to close up also this free for all, so at the moment we allocated this 300 terabytes for EUreka3D. So I don't know if when or what will be the next step, but this is allocated for the project. Whether to open it to communities, you probably need to get in touch with the project coordinator and see if we can accommodate your request in the project or within the workflow we are working for the community, things like that.
Something which is also very important so far as the few key objects concerned, because we are now at the test phase, we are going to host on the cloud all the information and all the data. Imagine you take your laser, you go to the site, then all the source data are going to be available for the use and reuse, not just only the model object.
Okay, I'll try to go. We don't have much time, so I will try to go quickly through the questions. One is, could you repeat why the logging service is so important for this project? I'm a bit lost what this has to do with digitizing 3D objects. So one of the main things is that once you digitize and you have your objects and you upload them to the cloud, you don't want people to change your object, right? You don't want to mess with your data. So you need to put a security layer on top of that always. So this authentication and authorization is not part of the digitization process, but it's part of the protection of the assets that you put in the cloud. you don't want anyone to go and change the model that you did with something else. So even in open data, you always need these permissions and this security in place for this. Also, okay, yeah, for the paradata, can you explain what does it mean? Consider an RDF-based solution related to paradata. We are working on paradata. So basically, is that the EDM model, the Europeana data model, is the one that we use for metadata. But for paradata, this doesn't exist at the moment in EDM. So we are considering to develop an RDF-based solution to store paradata. Why an RDF-based solution? So EDM is also based in RDF. So we are trying to put the paradata in a compatible format to Europeana. And RDF is, it comes from the web of data, and it's a data model, basically. It's a way of explaining or putting three subject, an object, and a predicate. And you can see an example here. I put here an example so you can, well, this is in XML format, but normally you can represent this in an easier way, probably. And you can say that, for example, Ignacio is the contributor of this object, for example. So RDF is important because it's a model that is a standard in the web or a recommendation in the web, and it helps you also to provide semantics through OWL and RDFS. So it's a bit of a complex thing, but I can explain. You can send me an email and I can explain. If you want to work with paradata and you need to know more about RDF, I can explain basically what it means. But it's a technology, let's say.
And from my side, if you are working on paradata, then it's a must. You need to contact us. We don't need to create here 2 times similar results or duplications. It's better if we join forces and we create something unique for Europe and for Europeana, of course. It's the first attempt at all to include paradata in the documentation, in the next generation of 3D documentations. And it's good if we can collaborate together. Why not? Please send us an email, contact us. And before that, it's advisable if you can read the results of the study, which are available in the online on the platform of the European Commission. Thank you very much.
So something else that is here, what is the role of the computing power? So the computer power is the other servers that we need for the project. In this specific case, I mentioned the visualization in Europeana. Why? Because Europeana is a platform that will show you the metadata and related things. But when you expose something in Europeana, like a 3D model, this object doesn't come from Europeana servers. It has to be provided by your server. So you are the one that is providing the visualization for Europeana, and they just embed it in their own website. So that's why we need some server that delivers this object, let's say, with a visualization library and things like that. So normally Europeana is just like this aggregator of distributed places, let's say, or sites, and one of them is EUreka3D. So to show this, we need this computing power. I'm not sure if this is answer correctly your question, but because we don't have much time, please send us an email and I can clarify. So how do you go from an individual 3D object metadata to a data set that you want to upload in Europeana? So basically in the workflow, we are now working with a single object, but we are trying to prepare everything in a way that we can upload data sets directly here. And as you can see, it's fairly easy. So you can drag and drop, you upload everything, and then we are working on the automation of things to collect the PIDs and these sort of things. And then we trigger the process to tell Europeana that something changed here, and then Europeana access us and show the results automatically, basically. the 3D visualization will be able to show meshes and point clouds or just mesh. So at the moment, the visualization or the libraries we are using, they deal with meshes. So there is also a project called AccioVision that we are exploring as well, and they base the rendering in two libraries. One is 3D Hub, one is Pottery, and this can also access point clouds. But at the moment, for the test, the initial test we are doing, we are only using mesh. How would you imagine the continuity and security of the data hub? Could the data hub be the only data repository for institutions for long-term preservation for valuable sheets data? Will be saved there 5 years, 10 years, 20 years? Or this is rather planned, it's a temporary repository, blah, blah, blah. Okay, so what we are creating here are the foundation of things that should come in future. So what we are establishing here is a pilot activity, let's say, but it's also the foundation for the future. So in here, I talk about the 3D visualization through Europeana, but this is just the beginning. We don't know what will come later. So we can find that there are other applications in different fields, like virtual reality or any other things that on top of this will build something. And this is the beauty of this. We are just preparing the foundation for next generation of applications in cultural heritage to come. So Data Hub is able to deal with this. Yes. So Data Hub is also, as Michael mentioned, it's a distributed repository. So it doesn't mean that the data is in one side. It accepts a huge amount of storage, and the data can be distributed in different places. So it's possible to do it. Yes. What will be the future of EUreka3D? This is something I cannot answer.
That's only the beginning. That's just only the beginning. And, you know, it's not about 3D. It's about setting up a knowledge. Of course, it's going to be EUreka3D Plus. And it depends also on the European Commission. It will be nice if we have the officer here. Do we have the officer here online? The officer can answer.
Yeah.
Okay. Nacho, let me also comment on the
EUreka3D can handle. So this is part of the work we are doing now. So we are exploring different. If you mention, I suppose you refer to 3D models, how we store the 3D model. So we are exploring different things. So for example, one thing that we explore is the Nexus format that was created by CNF in the past. And this is a very good format because it's a multi-resolution format. So when we deliver the object, you can deliver the object not in one place. So if it's a 3 GB object, you don't need to send the 3 GB at once. You can parallel the data sent to the user, and they can collect the object in different times. So initially, in the first 2 seconds, you can see something. But if you want to increase the resolution of the object, zoom in and things like that, this is sent to you little by little. It's a bit like the concept of Google Maps, that you see an image and then you zoom in and then you get more resolution to it. The problem with this extension is that it's not, there are some technical problems to deal with CAD models. So it's something that we might discard in the project for this. Apart of this, it's always a balance. So we need to consider algorithms that that are able to compress or they focus on compressing files and making files small, and algorithms that are prepared for performance. So we are contemplating all these possibilities, but we haven't decided yet which objects will be accepted. So at the moment, we are working with OBJ, but OBJ has a problem that is based on text, so it takes a lot of space. You can also zip compress because the entropy of the text is what it is, so we can compress it and send it to the user. But it's something we are exploring. We have also PLY, which is a binary format, which is better in terms of performance of the delivery of the object, for example. GLTF, we are exploring also this because it's using compression, or it has the ability to use compression. So we are exploring different models, 3D formats, sorry, but we haven't decided yet which one we will use. It's something that is part of our let's say, process. And we also depend on visualizers because we are not developing a new library for 3D visualization. This is something we cannot achieve during the time life of the EUreka3D project. So we rely on open source solutions, and we need to make sure that this solution accepts the object. But my impression is that we will choose something that is pretty standard. So normally pretty standard 3D formats will be allowed in the platform. And this is our intention, let's say.
I don't know if there is any additional questions or sorry because we are short on time
and I have to go
a bit fast on the presentation and also
on
the answers, but
yes, thank you very much, Nacho. Maybe there is a little more question from Tuli earlier in the webinar, where she was talking about how to input metadata. Is there some solution for easier metadata flow to EDM rather than manual input?
Okay, so yeah, we move past on this. So basically, the manual input of metadata that we did right now is basically for the test. So we were testing the communication between the EUreka3D platform and Europeana. We did it manually. The concept that we are exploring now in EUreka3D is basically use a sort of intermediate application like Mint that can deliver the format. So, for example, there is a content or cultural heritage institution that they might have their own repository with their own content, and they might use Mint to translate this initial format of the metadata into EDM. As per EUreka3D, we don't mind how the EDM is created. We just need to collect the EDM, and it could be through a tool like Mint, or it could be in any other solution. We will probably explore also other easy formats, because at the end it's just a transformation. So we can just put a form that people can input, and this will deliver EDM compatible objects that we can upload directly in the cloud. And the way to input this information here will likely be a drag and drop of a file, or it could be just to fill in something directly from a file. But we are exploring options to be as easy as possible.
Thank you very much, Nacho. And given we are already 10 minutes beyond our agenda, I think it is the time to wrap up. Let me thank all my colleagues, the speakers, the people behind the curtains at AGI who organized and managed this very nice webinar. It was a great success because we had over 80 participants connected. So I would invite everybody to keep following the developments of the EUreka3D project. We are midway, it's only month 12 for our project. We still have 1 year to continue development, and we are super happy to receive any feedback from the community of cultural heritage institutions and professionals and users in order to improve our platform and the services that we can offer in support to the common European data space for cultural heritage. That is the great initiative that is currently ongoing and will open up many opportunities for unlocking the potential of cultural heritage collections. With this, I thank you all again, and I'm saying bye-bye and keep following our project as other events will be organized in the coming months. Thank you very much, everybody.